Thanks everyone for being here tonight. Really appreciate this very special program hosted by Jewish Climate Action Network and Massachusetts Interfaith Power and Light. I'm Fred Davis, and I'll be leading off. Also moderating tonight will be Eric Grunebaum and Jim Nail. And in between are three expert speakers to present a fantastic case study. Shir Tikva, we're singing a song of hope tonight. We're hearing it from a congregation that made it happen, and the rest of us are incredibly grateful for giving us hope. I want to thank the donors who have given generously for this program and for to JCAN in general. It helps us put on programs like this. This is a case study we're going to see tonight. This is a case study. It is not a how-to. It is not a tutorial. Everyone will come here saying, how can I do this in my congregation, in my house of worship, in my institution? And those are all very, very good questions. We will not be able to answer all of those very good questions because every facility is different, is unique. Everyone should know, if you don't already, first thing you should do after you leave this is go find out how long. And by that, I mean, how long do you have until you have to replace your heating and cooling system or cooling systems? Somebody knows, or somebody can tell you that answer, and that is a critical question.
Thank you, Fred. Thank you all for joining us this evening. Happy almost daylight savings. I think it's next Saturday. Looking forward to this engaging narrative grounded on how a Boston area organization has managed to transition to a largely decarbonized facility, and we have the professionals here tonight who helped get it done. I'm going to very briefly introduce the three speakers at once so that we don't have to break between them. We have Richard Kaye, who's on the board of Temple Shir Tikva. We have Wes Stanhope, who is the CEO and co-founder of Building Evolution. And we have my colleague, Jody Renouf at GreenerU, who is VP of Operations. And then Wes will come back briefly, and then we'll go to Q&A with Jim Nail of Mass Interfaith Power and Light.
Welcome, everybody. My name is Richard Kaye. I am the board trustee for technology and operations at Temple Shir Tikva. I'm going to be speaking today about the hows and the whys of this HVAC project, how we got here, and our decision-making process. Wes and Jody will then focus more on the technology and the actual project implementation, the technical implementation. So first, just a quick overview. Who is Temple Shir Tikva? We're a Reformed temple in the Boston Metro West area. We're a vibrant, growing congregation with close to 600 member families. We run a religious school on Wednesdays and on the weekend. We have a 5-day-a-week early learning center that also runs a summer camp and also active educational, spiritual, and social programs. So very active community and congregation. So obviously we're here tonight to talk about heat pumps, but it all had to start with a need. And we had a need, as you can see, for a complete building-wide replacement of our HVAC system. And we'll get into the whys shortly. So the state of TSTs or Shir Tikva's HVAC systems. So back in 2021 or 2020, there were really two immediate drivers that precipitated this project. The first one being that of failing HVAC equipment, and the second being in the middle of the pandemic, indoor air quality. So this was 2021. The systems were at the end of life, nearing the end of life. Equipment was failing right on schedule. We actually had a building report done back in 2015. Actually, at the time, the temple was looking to, deciding whether to build a new building or keep what they had and know the expected life of the equipment. And so at that point, it's around 6 to 8 years were estimated for end of life for most of the equipment. But we were spending a lot in maintenance, even though we had an active preventive maintenance program in place, and we had to replace our rooftop units and around $40,000 just in 18 months. So it really just was not sustainable keeping this equipment going. The other thing, of course, old equipment, natural gas or fossil fuel burning, not very efficient. The older equipment gets, the more inefficient it gets over time. And being so heavily reliant on fossil fuels, this really did not align with our environmental mission, and we knew we had to make a change for that. As I mentioned, this was right in the height of the pandemic, and there were several things that really concerned us. I was also on the COVID task force at the time, and I learned very quickly that our existing HVAC system, first of all, did not support the use of MERV 13 or HEPA filters. And so if you're not familiar, HEPA is high efficiency particulate airborne filters. And MERV is just a rating, and really MERV 13 is kind of the minimum you need to get a HEPA level filtration. Older inefficient equipment can't move air through HEPA or MERV 13 filters, so that was a big issue. The other thing is the old equipment couldn't process any more outside air being drawn into the building, and one of the big remediators, I guess, of indoor air quality is bringing in fresh outside air. And the last driver for this, the why we had to get this done, is that the old system really was not flexible. It was very difficult, if not impossible, to control heating and cooling in different rooms on the same floor, different buildings. We had a lot of temperature extremes. And so all around, the system was ripe and ready for an upgrade. And one other thing to note, had the system been built today, it would never have passed current generation building codes. So before we go any further, I'd like to just draw attention to Temple Shir Tikva's environmental justice statement and just highlight a few of the points. This is on our website, but we must act with urgency in responding to climate change, and we make decisions to identify, carefully consider, and implement options to reduce climate impact. So very important, and we had this in the back of our minds the whole time. Actually, any project undertaken at Temple Shir Tikva, no matter how small or large, has to be taken on considering this environmental justice statement. So getting started, before we could get started, the actual work, we knew we had to put together a project task force, an HVAC task force. And this was important, first of all, to pick the right people. And we were lucky to be able to put together a team of people with different technical backgrounds. The Temple treasurer, who also had a lot of project management experience, was on the team. And that, of course, helps to get funds approved. We had a representative from TST's Environmental Action Committee, because we definitely wanted that input as well. And but the other thing is we realized none of us were HVAC experts. And so while we'd learned a lot very quickly, we realized we had to partner with an expert or a consultant, and that turned out to be Building Evolution Corp. We'll talk more about them later on. Obviously, with any project you've got to understand the problem. And even before this task force was put together, there was several months of really trying to understand what we were faced with and how we were going to deal with it. We also made sure part of this task force was to solicit user input, different building users. A lot of this came down to how we were going to fund the project. Communication to the community was so important, to really be as transparent as possible and really let them know that probably a fair amount of money was going to be spent. And then obviously this task force to work together throughout the different phases of the project with the different external parties to oversee the successful implementation of this heat pump switch over to heat pump technology. So some of the challenges that we anticipated and experienced going through the project, first of all, the complexity of the systems, very different systems. Shir Tikva wasn't one building built at one time. Different parts were added at different points in time. Different HVAC systems were put in. There was no real thought to integrating common control. And so just understanding, and that's where Wes and his team came in, understanding what we had was the first challenge. Then from our perspective, the HVAC team, understanding the proposed designs, because again, we're not HVAC experts, and these were very well laid out designs, and we had to make a decision of how to move forward and which one to go with. The cost of the new systems was, to us, exorbitantly high. That report that was done in 2015 estimated around about $350,000 for a HVAC replacement, and we were nowhere near that. We were several times higher, and we'll talk about costing later on. Getting Temple buy-in, we anticipated some resistance, both from congregants as well as even just the people working in the building and impacting their day-to-day, their jobs and their operations. Middle of the pandemic, supply chain issues was a very real issue. Anything, equipment delivery, as well as just costing, the cost of copper pipes or lumber was so high and fluctuating that that had to be factored into the cost of these proposals. Talked about impact on TST operations and just going about our business. And then there were unknowns, depending which solution we went with. Maybe the equipment was too heavy. Could the buildings support the weight of it? If not, then obviously you have to remediate that. So that adds unknown costs. So there was several challenges, but we really tried to identify them and work through them upfront. So BEC put together a set of 5 possible options. Of those, we considered 3 of them. We put together a pretty comprehensive decision matrix, and we narrowed it down to 3 that we were going to consider. Of those 3, 2 we seriously considered. And the first one being a mix of systems, a hybrid technology solution. The second being a full VRF, or variable refrigerant flow heat pump system. And Wes again will explain VRF in his section. Now I mentioned 3 options. I'm only showing 2 here. So let's call option 0 the third one. This was purely a replace in kind. So everything we had there already, replaced with modern generation versions of that. So gas burning furnace, air handling units, condensing units. We had to consider this. It was, financially, it was, half of what the next option was. And it would have been imprudent not to consider it, but really understanding that we were never going to get anywhere near to our target energy reductions, our efficiencies that we were shooting for. In good conscience, we couldn't proceed with that. So we eliminated that and then worked with these 2 options, which I'll now briefly explain. Before I do that, of course, these were not the final numbers necessarily, because we knew there were going to be energy incentives, rebates available for us. And one of the tasks we gave Wes was to find every possible dollar that we could apply to this project in terms of rebates. Proposed option 1, hybrid technology. So this was a mix of systems, and we really considered the building into 2 halves. It was 1 project, but 2 systems, separate systems. First of all, on the sanctuary side, just a replace in kind plus energy recovery and ventilation, or ERV, which just improves efficiency and ensures more outside air being introduced into the building. And then on the education and admin side, then go to more VRF heat pump wall hung units in the classrooms and the other open spaces and offices. Option 2 was a full upgrade to heat pumps. And this would then give us the best possible energy efficiency, maximum comfort and control, very granular control, definitely the lowest environmental impact and significantly reducing our carbon footprint. But of course, this was expensive, much higher than some of the options. But in reality, when compared to option 1, it wasn't that much more. When you get up to that point, a couple of $100,000 here or there, it doesn't seem as significant anymore. Also, very efficient system addressed with ERVs and being able to support the highest level filtration that we need. Of course, moving to almost full electrification, the next obvious step would be to consider a solar power installation, and that was immediately started. That project is ongoing, and it's being managed by the Environmental Action Committee. So now I did say almost full electrification. We did need 1 small gas burning boiler, a high efficiency boiler, but much smaller than what we currently have. And then also the recently installed RTU that was, I think we spent $20,000 or $30,000 on. We just didn't see the point in pulling that out. So we did leave that up there. Ultimately, this was the option that was approved. So how did we accomplish this? How did we do it? Well, these were the main steps and who was kind of responsible for them. I'm definitely not going to go through all of these, but 2 points I do want to highlight here. The first being the value of this building study that we had BEC do for us. First of all, it just gave us a baseline to know what we had, what we were dealing with. And they didn't just look at it from an HVAC perspective. They looked at it from the whole building system, whether it was lighting and airflow and obviously temperature control. And it also gave us a lot to think about moving forward for the next 5, 10, 15 years. This is a document that we really can use. It was focused on HVAC, but there's a lot in there. And the other thing, working with a consultant, environmental building consultant, you're getting an unbiased report there. This is not an HVAC manufacturer or a contractor who likes to sell product X and knows that product and is going to suggest it. This really did consider all possible options. The other thing, of course, is how do you pay for this project? And this was a big one. And so to secure project funding, how did we do that? What were the steps? First of all, we presented the options to the board, and monthly board meetings, we kept them up to date of what was happening. We had Wes and Building Evolution present to them as well, just to kind of keep them up to date. We presented the options, and they approved, overwhelmingly voted on and approved option 2, the full heat pump replacement. But it was going to take a new mortgage, a second mortgage, to pay for it. And as soon as we have to take on, if we have to take on a new mortgage, that immediately triggers the requirement for a congregational approval. So we held a town hall. Everyone was invited. We also held it on Zoom. We showed the options. We explained what was going to happen. Took Q&A. Again, overwhelmingly approved. And also we were able to show that this whole project, the mortgage, would be able to be paid without any impact to congregant dues, to the building fund, as we had a very well thought out payment plan for this, for the new mortgage. The last piece of this is really just to talk about the timeline. How long did it take? So from the time of the, say, the formal kickoff of the HVAC task force or committee to flipping the switch and having a warm building in December 2023 was around 18 months. How that was broken down was as follows. First of all, there was the study and report, and that was Wes and his team, which took back and forth for quite a few months, 3 to 4 months. After that, once we had decided on our the design option, Wes took it back and worked with their partner engineering firms to come up with a very detailed design for the complete system. Also, part of that deliverable, the next part of that deliverable was a very comprehensive bid package that we put out to selected HVAC contractors. And after careful vetting of the contractors, reviewing their proposals, we selected GreenerU as the general contractor for the project. And GreenerU, just their whole philosophy, how they work, their approach to things really fit very nicely in with what our needs were. And so you'll see up here a gap in this. And what's the gap for? Well, startup delays. As anticipated, equipment was delayed due to COVID supply chain issues. This actually helped us because we managed to flip the whole schedule on its head, do the sanctuary later on. So family members who were concerned they wouldn't have air conditioning in the summer for their events had air conditioning. We did the ELC first, and it really did ultimately work in our favor. So we anticipated around about a year, a full 12 months to complete the project and commissioning. In fact, it actually took around just under 10 months to complete, and right on budget. And I can't think of a better way to end my section than saying on time and on budget.
Just want to take over from where Richard laid all the groundwork on all the hard work we've done over the past year and a half. I know there's a lot of terms that were said within that presentation. So I know in some meetings where we go through a lot of the terms like VRF and ERVs, and it's kind of like you know, going plaid over some heads that aren't in the HVAC world. So just want to go into some of the terminology here. You know, very quickly, like boilers, you know, they're devices that make hot water to provide heating to those spaces. And we got to hear AHUs, or air handling units. There are these metal boxes in buildings that will move air, and it can provide hot air or cold air to the buildings for heating and cooling. And an RTU, or a rooftop unit, well, it's that similar metal box, but it's weatherized and sits on top of the roof. So TST, it had air handling units, and it has RTUs. An exhaust that pulls air out of a building, which is opposite to the supply air, which is pulling into the buildings. Most buildings are going to have exhaust air. And CFM, cubic feet per minute, that's how you measure air. That's how much air is moving in or out of a building. And when we're talking about heat pumps, usually somebody's saying, well, my heat pump is 5 tons in size, or your heat pump's 8 tons in size. Well, a ton, that's a unit of measurements for the condensing units. That's how large the actual heat pump is, and 1 ton is 12,000 BTUs. And, well, here's the actual types of systems we're talking about here when we're talking about heat pumps. So on the right, top right, you can see an outdoor condensing unit. So it's an air-cooled condensing unit. That's the system that sits outdoors. And you'll hear ACCU, or you hear someone say a CU, a condensing unit. That's the terminology for the box that sits outside and pulls heat from the air outside to put it into the building, or will reject heat to the outside in the summertime to cool your building. And if you have a fan coil unit, well, that's the indoor unit that's on the picture on the bottom right. That's going to be in the space, or maybe it's hidden behind the wall or in the ceiling and is ducted, but is transferring the heat to the space to actually do the heating and cooling. So that's the fan coil unit, or FCU. So it's just some of the terminology that we'll be using, or you'll be using in your own projects in the future for heat pumps. And when you put the whole system together as a heat pump system, they're all variable flow. So it's a variable refrigerant flow, or VRF system. And that's where you have your outdoor condensing unit, that box that's sitting on the grade or on the roof of your building, and is connected with refrigerant pipes to your fan coil units indoors to provide the heating and cooling. And some units, some types of VRF systems, like a couple of the systems in the temple at Temple Shir Tikva, has simultaneous heating and cooling, so that rooms could have heating or cooling in adjacent spaces, and that helps improve comfort in spaces. So a heat pump system is a temperature control system to help control comfort in spaces. Well, here's the HVAC myth. Heat pumps don't work when it's cold outside, and this one here we're going to say is busted. There are different types of heat pumps. And there are ones that we'll call, let's say we're using Mitsubishi in the TST. So in Mitsubishi, they have what's called a standard heat pump. And a standard heat pump, if you were to purchase one in our climates, it wouldn't work. So we wouldn't want to purchase a standard heat pump. If your building is in Georgia or Florida, that would work fine. But in Massachusetts, that is not a climate appropriate heat pump. So when usually this rumor happens is because inappropriate selection of an actual heat pump for your climate. In our climate up here in Massachusetts, we would want a hyperheat or a high efficiency heat pump, depending on the building load or what part of the state you're in. If a hyperheat, the table you have on the left, at about 0 degrees outside Fahrenheit, you're at over 100% capacity of that system. If you're at a high efficiency system, you're at 82% of its rated capacity at 0 degrees. So in that design day calculations for a lot of places where, like say, Temple Shir Tikva is, that is actually lower than the design calculation for the building. So either system is suitable for Wayland, Massachusetts, where this project is located. Energy recovery ventilation, or ERV, is a ventilation system that's going to use the exhaust air to precondition the incoming air. So you're going to provide fresh air to the building, but without having a penalty of energy, or not as much of a penalty of energy. Because in the wintertime, it's going to be really cold outside, and you bring in that cold air, it's going to require a lot of energy to heat it up. And in the summertime, for those who are in Massachusetts will know it's usually hot and muggy outside. So it's going to take a lot of energy to cool it down and dehumidify the air. If you're already conditioning the space indoors and you're exhausting that air, you're wasting that energy. So the energy recovery ventilation recaptures that energy by preconditioning that outdoor air, but it's not cross-contaminating the air streams between them. So you're still getting that fresh air into the space, but it's already preconditioned most of the way to the temperature and humidity to where you want it to be indoor conditions. So how was TST originally? Well, as Richard was saying, there was a lot of different systems on 2 different buildings built over the years. And there was a mixture of air handling units, rooftop units, boiler, there was hydronic, there was furnaces. There was a lot of different systems that were cross-connected between the 2 buildings. And it made it more complex to try to zone for temperature control and also for maintenance. For example, this was a sketch I put together for just the sanctuary and social hall side of the building to try to make it easier to understand how the actual space was controlled and conditioned. Still didn't make it that much easier. But you have here's the actual sanctuary side. You have air handling units conditioning the spaces, but they are all disconnected from the boiler on the other side of another building that's providing heat to them, and cross-connected each other with ductwork. Here's an example of the actual systems. So air handling unit to move air on the left-hand side with a cooling coil inside of it, but a heating coil is in a different location for the same system because they're not integrated with each other. That all made it even more complex to control the system and try to maintain space temperature. As Richard mentioned, it was good time to start looking into upgrades for this building. Another thing about control, the left-hand side of this is the educational side of the ELC, and there's classrooms that are wrapping around the semicircular side of the building. And in the morning time, the sun comes up on the east side and will start to overheat some of the classrooms. But it's all zoned as one temperature control, one air handling unit. That same air handling unit also does another zone in another part of the building. So if you have somebody with a temperature, one thermostat right in the middle, and their temperature is just right, you're going to have one space overheat and another space that's too cold because they're losing heat through their glazing. Not an ideal situation to try to keep multiple classrooms with children and teachers satisfied for temperature. So it's a good opportunity when systems are coming towards end of life to look at what can you do different. And looking at the types of systems, boilers on the left-hand side, in the middle, that's a hot deck, cold deck system. If anybody's ever heard of those, that's a furnace that burns natural gas while simultaneously providing cold air to mix the two air streams together to try to maintain an actual space temperature of the space. Wouldn't say that's really a high efficiency system. And then the old RTUs on the roof, which are furnaces. So it was a good opportunity for buildings to do an upgrade. At the same time, not to improve comfort and indoor air quality. Looking at those same classrooms, that was an opportunity to rezone. So each classroom now becomes its own zone for temperature control. So remember, a variable refrigerant flow, VRF heat pump system, is a comfort system, temperature control system. Each classroom can independently control temperature. This is a heat recovery VRF. And each classroom, but all these classrooms are also provided now with fresh air and exhaust going through an energy recovery ventilator, increasing indoor air quality. But that exhaust that's there is now reducing the load because it's now transferring through an ERV instead of just being exhausted to the exterior of the building. I'm going to take a pause. I'm going to hand it over to Jody.
All right, so now the fun begins, construction. So once again, I'm Jody Renouf. I lead the operations team at GreenerU. And I'll show you how the steps of this complex project unfolded and the effort to minimize impact to people and programs. So planning considerations. But before I get into specifics, I want to offer a little bit of background on GreenerU. GreenerU can help organizations through their climate action planning process, then can provide project development and engineering services, and then we implement those projects, or any combination of those. At Temple Shir Tikva, we took only that final piece, which was implementation. Delivering energy efficiency and infrastructure improvement projects in occupied buildings and busy campuses is what we do for houses of worship, schools, universities, research labs, museums, medical facilities, and all that. So when selected for construction at Shir Tikva, we were up for the challenge. Working in occupied buildings, it takes very careful planning and communication. When we bid out a project, we have a selected group of subcontractors we work with who know how to work in occupied buildings, the sensitive nature. The goal is to allow the programs and business to carry on as normally as possible with minimal interruption. So it needs to be a high level of public safety, in addition to the high level of contractor safety, while maintaining usability of the spaces to some extent, and having a generally good appearance at the end of the day or work week. And planning means listening to and understanding Shir Tikva's needs, such as running the preschool programs at the Early Learning Center from September to June, regular religious services and programs, and the provisions for staff that support those programs, summer rentals like the weekend B mitzvahs in the summer, and other rentals. And then for the temple, the high holy days and other days when things just need to work. Scheduling. So when planning a project schedule for work in an occupied building, there are really good reasons to do the work in phases. In fact, it's generally how you kind of have to do it. Project schedules can be multi-phased for technical reasons, like HVAC zoning. Here at Temple Shir Tikva had the classroom side completely really separate from from the sanctuary side. And so that was one thing to consider. And also the building usage. So the programs that were being maintained, we needed to finish the work in the early learning center in the summer. It needed to be turned over for classes to begin in September. So things like that, also considering in the schedule. And then site work was needed at Temple Shir Tikva. The trenching and electrical conduit in the right, picture on the right there, it was done in early spring, so before any outdoor activities were planned, even though the wiring that was in there wasn't actually needed until like the end of the project. And that was just to really work with the programming and making sure that we could accommodate those outdoor programs. So why the trenching and electrical? Why is that needed? Site electrical improvements are sometimes needed with heat pump projects because the heat pumps are electrical devices that are replacing gas burning equipment that really doesn't need much electricity. Like gas burning equipment didn't really need much. So you may have to run electrical conduits, as we see here, on site, or in some cases running a new electrical service to the property. And then the other reason and other things to consider with phased approaches is cost management. A house of worship may split work over multiple years due to fundraising, budgeting, capital planning in general. But no matter what the reason is, it's good to consider how the project is going to be phased early in the project, well before it starts, during upfront design and engineering, if you can. You can kind of think about it in those puzzle pieces. Then there are unknowns. So Richard had mentioned material lead times and the project completely flipping on its end. And we actually ended up with a very good project schedule that better accommodated summer programs. But that was all due to that electrical panel there shown on the left that was ordered in December of 22, expected in like April, May of 23, wasn't received until August, September. So that's the thing that needs to be considered also in the project schedule. As soon as you can order material, it's super critical to ordering. And I mentioned weather here because we have those hot April and May days. We have early frosts, things like that. There are going to be weeks or months that there's no AC or heat in parts of the complex, parts of the building. And so we need to plan for that too. And how do we make sure things keep moving and no one is surprised? Regular communication. So it's critical to all the above and minimizing the impact to people. Weekly GreenerU facilitated progress meetings with our team, Shir Tikva staff, HVAC committees, and of course Wes. These meetings were followed up with emailed weekly work summaries and a 2-week look ahead, so we can kind of let people know exactly what was going to be happening, avoiding unnecessary surprises. And here's some pictures of the work in progress. On the left, these are both mechanical rooms. One of them is demolition, so those units are being taken apart. And in the other one, you see installation. And you see all the people in the photo on the right. One thing you may not know is it took 8 different trades, so 8 different construction crews to implement this one HVAC project. Thankfully, not all the 8 crews at the same time, but it did make for a lot of Friday donuts. This is behind the scenes, so these are mechanical rooms. But what happened? What does it look like to the congregation? What does it look like to renters? And so here we kind of see some accommodations, some construction in progress here in the front-facing side of the building, or user and congregant side. So the carpet runner there on the left allowed for the sanctuary to continue being used in a more elegant way of protecting the floor from construction traffic and boots. So we were able to maintain some order. On the right, and you can get a sense of the walls being cut open for all of the ductwork rework and refrigerant piping, wiring, piping, all those trades doing their work. So there was some cutting and patching, and it was obvious we could not have the preschool open during this time. And then after the work's done, we try and leave it in better condition than it was, the same or better condition. And so on the left-hand side, you see one of the completed classrooms with a new fan coil unit on the wall. And then on the right is some of the outdoor equipment, some of the rooftop condensing units. And after installation, it's good to provide multiple training sessions and a quick reference guide in addition to all the 5-inch binder that you end up getting, so that it's more user-friendly and the people who are using it can continue to use it in the way that it was intended and maintain their comfort level as it was designed. So with that in mind, I will turn it over to Wes to talk about commissioning.
So now that the project has come to a completion on the construction side, it is important to test the actual equipment to make sure that it functions as designed. So it's going through all the testing through different modes of operation to see what works, any issues, any snags along the way. And you can see Rob in the bottom right corner doing testing down the ERV in one of the rooms and the mechanic room in the building. But it's going through all different testing and then monitoring and independent monitoring of all different spaces, going through different modes of operation. It's a key function to ensure if there's anything caught at the end, if there's a piece of equipment that's not functioning correctly, if there's any control setups that need to be changed. It's a very important last function before operations and handover. And just look at the mashup of systems. Here we have on the left all the different types of ages or types of equipment, furnaces, boilers, condensing units, a whole mash of all different types to try to maintain hot deck, cold deck, RTUs, and then controls. And that top left picture, how would you even access that, which Richard might get a chuckle about, versus the new system. The new system, we just had condensing units to fan coil units for RTUs, for the condensing units to fan coil units for the VRF, and then ERVs. It's very simple. Simple to maintain, simple to operate. Whereas all the systems on the left were hard to operate, hard to maintain. And I took many different types of, like Jody mentioned, a manual to try to maintain the new systems are going to be simple to operate and maintain. The older systems, each one were different. Each one had different types of maintenance. Each one had different types of control to try to make it work. And then the controls did not necessarily function properly. Whereas the newer ones, they're all kind of uniform on types of system throughout the entire building. So when we're talking about the different options for upgrades, and then not choosing the hybrid, but choosing the option where they went to full install for the VRF, this will make it a whole lot easier to maintain and operate going forward. So that is a consideration. So Richard kind of alluded to the costs at the beginning. It is a good question about how much did this cost. Well, here we go. So the hard costs was $2,148,000 for the construction. Soft costs for all designs and studies was about $200,000. Incentives, the heat pumps for the VRF in Massachusetts through Mass Save was $352,000 to offset that construction cost. ERVs, $804. So the big one was the VRF to go heat pumps. That really helped the decision making for this project. Now, talk about the impact on the environment. We talk about the comfort, the maintenance, indoor air quality, but part of it is about the decarbonization and electrification of this project. And the HVAC, it's just the beginning. So I want to step back. There's site energy and there's source energy. So site energy is anything behind the meter. what's in your building. So after your electric meter or your gas meter, or even if you're getting coal delivered to your building, if you're still doing that, it's what your building is actually using on the site. That's your site energy. So an example here on the left, if you have a boiler, you're going to lose some of that energy that you're burning from the gas. It's just going to go up the flue, and that's just boiler loss. The overall system itself, going through the building, overheating, other inefficiencies, it's going to lose energy as well. So there's going to be some system loss. You'll maybe have about 70% of that natural gas that is burned in the boiler or comes through the gas meter is actually useful heat. So that could be kind of measured and calculated on site for the site energy. Then there's the electric meter. Well, you back up that electric meter or that gas, it has a loss or it has a grid that has to bring the energy to site. That's the source energy. Now, looking at ISO New England, which is the power grid for New England, here's where the energy comes from. So to provide electricity to the electric meter, it comes from a whole mix of all different types of energy sources, including fossil fuels. So you have fossil fuels, renewables, nuclear, all different types of energy mixes. So when we do go over to electric, we're not going to be fully decarbonized yet. We're going to get there though, but the only thing that we control is what we control in our building. We don't control ISO New England. We don't control the power plants. So we control what's in our building behind the site, behind the power meters. One other thing we want to just touch on is there's a distribution loss. So you have a power plant that could be 100 or 200 miles away. It's going to lose a bit of electricity by the time it gets to the building. There's a loss of electricity through heat. It's just the way electricity works. And there's a renewable mix in that power grid, the ISO New England, if you're up here in New England listening in, and there's emission factors. So right now, looking towards the future, more of our electrical grids are becoming renewable energy. Here's ISO New England's projections to 2040. Rhode Island should be at 100% renewable. If you're in Massachusetts, where Temple Shir Tikva is, that should be about 50% renewable by 2040. So where you're purchasing electricity from should be at a higher percent renewable over the next few years. So if you could shift your building to an electric and a high efficiency electric system, you're getting onto the right path. The emissions factor is taking into all that into equation. So it's taking in that ISO New England mix, if you're up here in New England, it's with the renewable energy production and the distribution losses. And an example of that is Birdo. It's looking at all that mix and looking at what your emission factors are for the electricity in that grid. So electrification, why don't we just go electric? Well, you can put an electric boiler in. On the left, that's an electric boiler from a project that I had pulled out. If you just put in an electric resistance heating or an electric boiler, you're going to increase carbon on the planet because that has a COP of 1, coefficient of performance of 1. That is not the way to go forward. You're better off basically with a high efficiency gas boiler. You're going to have less carbon impact in the world. You need to have a heat pump. A heat pump has a COP of, on average, about 3. It's seasonal. But that means it's going to be about 3 times more efficient than an electric resistance boiler or electric resistance heating. It's key. Heat pumps are key. I just want to have that point inside here for, why did Temple Shir Tikva and other products go heat pumps? So when you look at the Temple Shir Tikva, shifting that natural gas heating, 85% of the natural gas that was there got shifted off to electric and all to high efficiency heat pump heating and cooling. There was a small amount of the actual building that remained on natural gas. Richard did point out that a small little, kind of like a baby boiler, remained on site. The only reason why that remained there was because the electrical grid for the building could not allow for any more electrical consumption in the building without upgrading the service of the building. And that could have taken 1 or 2 year upgrade process, which weren't able to wait for. So that's why we're at an 85% site reduction and not at 100% offsetting all natural gas off the site itself. How does that translate? So looking at that, take into account the renewable mix for ISO New England, the distribution losses and whatnot, and you look at that, it's about 25% right now, 25% reduction in carbon for the source energy. But what if you were to start to reduce how much source energy you need? What if you start to put on-site renewable so that your site is now producing the electricity that you need, you don't have distribution losses, and you don't need it from the source, which right now is not fully renewable. So Temple Shir Tikva is, next step is to put in solar canopies and rooftop solar where it makes sense. That's not going to be in shading. And that is going to offset about 90% of their electricity. Their electricity is going to bump up. I've done the calculations. I'm going to bump up a little bit with the new VRF. It's not too much more. It's going to go up by about 20 or 30,000 kWh. And how does that actually translate? Well, if you look at that 85% reduction by going over to electric, you add on that on-site PV, that source reduction to the projected energy use with the VRF now becomes a 68.5% of source energy reduction of carbon, carbon. But that's it today. So as that grid starts to become greener, as that grid starts to become more renewable energy, and like Pac-Man, that blue starts to get smaller and the other non-renewables become smaller and the other ones, the renewables start to get bigger, that actual carbon reduction becomes larger because the grid becomes cleaner. So we can only do what we can manage, which is our building. And through policies, the National Grid, Eversource, and through ISO New England becomes a cleaner grid.
What we're seeing here is a very happy group of people. These are all members of, I won't say just the HVAC task force, but some of us from the HVAC task force, the GreenerU team, Temple Shir Tikva's executive directors, treasurer, Wes, and this was a very well-deserved celebratory dinner we had at the end of the project back in January. And I think a great way to end the presentation. Everyone is still smiling.
Hey, hi, this is Jim Nail. I will jump in here and moderate the Q&A. We've got a bunch of really good questions that have come in. So I'll start with those. And if other people have questions, either keep sending them in or, again, raise your hands and we'll let you unmute and talk. But I guess we had several people ask the question of, did you consider, geothermal / ground source heat pumps? And if so, sort of what were the factors you thought about?
I'll do the quick, and if Wes wants to add anything. So we did, what we found is if you have a greenfield installation or new building, it's absolutely a great thing to consider. But when you have space at a premium, and we already Shir Tikva is about as far up against its borders as it's legally allowed to be, and we share with Camp Chicopee next door, it really did, for it to have any impact, we would have need to put a pretty significant system in there, and it just physically it just didn't fit.
Yeah.
I'll just add as well that if you have an existing hydronic loop, maybe a condenser loop system, it would really make sense to consider the geothermal because it works the condenser loop. And that, what a condenser loop is a low temperature, 70 to 90 degree water system where you have water source heat pumps in the spaces for doing heating and cooling. And that would be a no-brainer to look into. With Temple Shir Tikva, it was a mixture of furnaces and air handling units that was air-based systems that were decentralized from each other. And it would have been a high cost of installing the infrastructure for that, for the condenser loop for geothermal.
Great. There were also a couple of questions about what is the expected life of particularly the VRF equipment. But if you could, I think it'd be helpful to everybody if you could give a sense of, the VRF will last like this and traditional RTUs and AHUs are going to be these many years, and just sort of give people that sense of what, partially what they can look for in their own houses of worship.
Yeah, I mean, the VRF would be 20 plus years anyways for like the outdoor units, condensed units that are out in the weather. If you have air handling units, which are RTUs that are up on the roof, they're going to be a similar lifespan because they are out in the weather as well. That's the consideration. If you're out in the rain and snow and all that, they're going to have a similar issue with lifespan being out in the weather.
Okay.
Whereas equipment that's indoors is going to be, if they're well maintained and kept indoors and nice and dry, things last a bit longer.
Right. So I'll make an editorial comment and correct me if you disagree with me. So if you have this kind of equipment in your house of worship and it's, say, 15 years old, time to start thinking about and start that early planning of what you want to do with it to replace it.
Well, it's always good to have a plan. Even like I do that sometimes with some clients where they're looking at what's the 5, 10, 15-year outlook. Because there might be enclosure upgrades that are required sooner. And sometimes the enclosure upgrades might impact what they want to do with other aspects of the building.
Yeah. Richard, these are probably for you. There's a lot around financing. But before we even get into any numbers, there was a question about, so, how much, pushback did you get from the congregation? What sort of objections did you hear? How did you handle those? I think that gets into sort of what was the messaging you brought to the congregation, and, what would you suggest for other people as they're thinking about these kinds of projects?
We were ready for the worst. I have to be honest. We really thought we were going to get a lot of pushback, not on the technology and why we were doing it, but the cost. And really, it was almost nothing. The fact that we had a solid plan to pay for it, that it wasn't going to impact dues or building fees. There was just, I think everyone knew it was the right thing to do. We had such compelling reasons between, the air quality issues and, we're trying to reopen the temple, but having bad indoor air quality wasn't a very attractive thing. So it's like temple's dealing with security issues. You have to do it, right? And people just accept it, and there might be some pushback, but it's the world we live in. And in this case, like with the HVAC, it was something that had to be done. And, we, as I said, the monthly executive director reports were all very transparent, exactly where we were, what we were considering, that there was going to be a vote coming up, and we were thinking it was going to be much higher than anticipated, and those were all taken very well. And I'd say a lot of the silence we took as an endorsement of this.
And when you were doing the evaluation of those two options, the hybrid versus the full VRF, was there like a payback analysis done between those two options? And how did that play into your decision?
I think, Wes, did we do a payback, or was it more just kind of I'm trying to think back now, it's about 18 months since we, that part of the project, yeah. 2 years almost.
We didn't necessarily look at a simple payback on projects. It's more of the overall cost delta between them, and then impacts of the actual, what are the impacts of the actual project? So like, one thing to caution about simple payback is that it's too simple of a calculation. That if you have something that has like a 5-year payback versus a 3-year payback, would you do the one that's 3-year because it's shorter? But what if the lifespan was only 4 years and the 5-year payback was 20? Right. And if the 5-year payback one tackles indoor air quality, comfort, and maintenance at the same time. So there's more to look at it than just simple payback. I would look at like internal rate of return or life cycle costs, as well as other non-monetary impacts.
Right. So talking total cost of ownership as opposed to that simple sort of a simple payback based purely on the operating cost is what you're saying. Yeah.
And of course, higher incentives for full VRF versus seatbelts.
Right.
That's another thing that gets factored in.
And another question was what was the interest rate, or how did the interest rate, affect, the decision?
So again, I'm not the treasurer, but I found the treasurer's presentation, and this was done at our annual meeting last year. So it's nothing proprietary here. I think it's worth sharing. Let's see if I can share this on screen number 1. There we go. So everyone can see exactly what this was all about. So here's the breakdown. So currently, when we signed, I think it was 5.3%.
Good.
It was one of these loans where we only started paying once we wrote the first check to whoever was going to get it, which was probably GreenerU. This was something that didn't require any external audit, which was good. I mean, that it was approved pretty easily. No environmental appraisal, which of course then reduced our closing costs. And then, of course, no prepayment penalty. And then the other, here's the last thing. So annual principal and payments, and we're paying, and this is an important bullet up here. Through borrowing, supplemented by existing funds, we tapped into the building fund, and then also looking at available incentives. Yeah. Hopefully, this answers some more questions that were asked, but I think this is also good information here.
Yeah. So great stuff. So moving on from sort of the upfront construction costs and things to the operating expense, sort of how was that looked at in the planning phase? And then I guess the system's been operating for a couple of months. Any observations about how well it's tracking to what your expectation was? And I think, one of the questions about heat pumps, given the relative high costs of electricity and the relative low costs of gas, is, how is that sort of netting out in the operating cost?
So the interesting thing is we've been tracking the Environmental Action Committee, who's heading up the solar project. We've been trying to get ourselves into another rate category with Eversource. You kind of hit a certain threshold, and we knew we would get into that category. I guess the more electricity you use, the cheaper it becomes. Maybe Wes might be able to explain that a little better. But so each month, and we knew once we flipped the switch on, first of all, on the education side, and now with the sanctuary, now we've gone full electrification or close to full. Our rates, we've put us into a certain category now that I think that was like the last trigger that we were really looking for to now really go ahead with the solar project. And I forget, and again, not being as involved in that side of it, I know we have some folks from the Environmental Action Committee actually on the call tonight. That's a topic of another presentation. But it's, electricity is expensive, but it is our latest bill has put us into a lower rate category. So our bills are going to start going down now slightly after the last few months. And 2024 will be the year of solar at Shir Tikva. So that should, and we'll probably go with a power purchase agreement. I don't think we have the stomach for another big mortgage. And but still, that's to lock into a rate for so many years is definitely very attractive to the temple. It certainly helps with budgeting and what have you.
I'll come back to solar. I wanted to get to a couple of other questions around, again, now getting into operations and maintenance. There's one question that came in, are there any safety concerns when you have these very long runs of refrigerant piping around the building? And is there a need for like annual maintenance or annual inspection to make sure there's no leaks in that system?
There wouldn't be, no. So there wouldn't be any issues or concerns. So when you're designing an actual heat pump system, anything to do with refrigerants, it does have to be designed to any of the regulations, restrictions to do with ASHRAE and codes around refrigerants. Most of the concerns when it comes to refrigerants are usually based on chillers, or that's where the concerns in the past have been, because you have a really high pressure chiller inside a confined space that could have an issue. With modern day VRF technology, they are designed with a lot of fail stops in them, or at least where if there's a refrigerant leak detected, they could start to reach, like I know Mitsubishi and Daikin, they can pull the actual refrigerant back to the main condensing units to try to extract any refrigerant if it senses a leak. There's different ways technology they implement with it, and the amount of refrigerant in the system versus the volume of the space, especially like in larger buildings or even your homes for heat pump the size of your home, it's going to dissipate within the volume of the space and not have any concerns. Where, just to give you an example, I know where this would come up, because like if you had a VRF of this size, that you had a fan coil unit in a small little tiny closet, and that entire condensing unit was serving that closet for some reason, or connected just to that closet, that would be a concern if that 16-ton condensing unit on the roof was connected to a fan coil unit just in the closet and then discharged all of its refrigerant to that closet. That would be a concern. But where it's connected to, say 13 classrooms and all other locations and over a larger volume, there wouldn't be any concern with it. That's probably a long answer about trying to give examples of where it could be.
Because I think that was one of the points that you were making about the old system was so complex with so many different pieces of equipment that this is a simpler system. And so in addition to, again, back to our discussion of total cost of ownership, you're spending a lot of money on just even the routine maintenance and annual tune-ups of all these different pieces of equipment compared to the existing system. What's kind of the expectation of that?
Yeah. So with these systems here, the main type of maintenance you're going to have throughout the year is cleaning of filters on indoor units. So you have fan coil units that need filters replaced seasonally. Mm-hmm. And then ensuring that the coils on the outside are kept clean, because it's a heat transfer, air over the coil. Those are the key things. So both the coil on the inside is kept clean, which hopefully is done by filter replacements, and that the outdoor unit it's cleaned, whether it's twice a year. It depends on. Don't plant shrubs next to your condensing units, because you're going to get pollen in them and you're going to be cleaning them a few times a year extra. But it's going to be a case of making sure they're kept clean, so washing them. There's an enclosed system. Once it's piped and it's sealed up, it's an enclosed system. Mm-hmm. Most components came from the factory. It's not field fabricated, besides the pipe work between them. So it's a lot simpler for maintenance on site.
There was also a question about with the VRFs. Did those require new ductwork? Were you able to reuse existing ductwork? And particularly if you had to put in new ductwork, how did that affect the overall cost of the project?
I'll just give that was one of the options. So one of the one was the hybrid, which was VRF with existing ductwork, and the other was VRF with new ductwork. And that got so close to full VRF that we just threw that one out, and Wes was able to, and his team were able to design a system that could use most of the existing ductwork. And if you want to add anything to that, but that was one of the 5 choices presented to us.
Yeah, that's fine.
Is that it?
I kissed that Barney Stone twice, so I could just keep on going.
Yeah. All right, well, let's move then into some of the solar questions coming in. And there's one question about does Wayland have a community aggregation program, and is that an option as opposed to installing your own solar system?
I don't know the answer to that.
Yeah. Okay. Fair enough. So it sounds like you're pretty well along the way of considering the solar system. You're working with an installer. It sounds like you've got some proposals. You alluded to power purchase agreements, and maybe define that and what the benefits of that are for the folks here. And yeah, again, if anything, I know this is a different group doing this, but any, tips and tricks of presenting that to a congregation.
Wes, do you want to take that? How are you up on solar?
Nothing.
Well, I guess. Go ahead. No, I was going to say at a real high level. So you really have two choices, from what I understand. One is you own the panels, so you pay for the installation, you maintain them, and the power is all yours. It goes straight into your building, and it's yours. You can sell back to the grid if you are producing more than what you need. The power purchase agreement, in its simplest form, is a third party, another company, was responsible for getting the permitting, doing the buildings, installing and maintaining the panels. They own it, and then you pretty much lock into an energy rate. So they're making money by selling it for the next 20 years. Essentially, they're leasing your property more or less to put their equipment there. And the one benefit you get out of it is low electricity rates. I think that's probably the simplest way I can explain that.
And I think, the other benefit, because I've seen a lot of those kinds of agreements with a lot of the houses of worship I've worked with, and it's not only low, but it's also the contract tells you year by year exactly what the rate's going to be. Right. So none of these crazy things like last year when rates spiked up to, like, at least in grid territories, it was like 40, 45 cents a kilowatt hour. You're protected from all of that.
Right.
Yeah.
I mean, I think you don't qualify. They get the all the incentives because it's not your equipment. So it's, and it's, if it needs a new roof, they're going to probably take care of that or incentivize you to get that done before they put the panels. It makes sense for them not to put panels on a roof that needs to be replaced in 6 months. So.
Yeah. So I guess the solar would be something of a backup system, but are you looking at batteries with that solar, or was there ever any discussion, since you're now all electric, having some kind of backup like an on-site generator in the event of a big power outage?
I think that was a discussion even going back a year and a half ago. Did TST want a generator on site? Because there wasn't one to begin with. So if there was a loss of power, there wasn't any heat or lighting on site. And we discussed, so if you have a generator, it's kind of easy. It's a good discussion. It's kind of easy to run a boiler because it doesn't use that much electricity. It uses a lot of natural gas or oil or whatever your backup system has to provide the heating. If you're having a VRF system, like for this building, I would not size a generator to run the entire building. That will be a trailer truck, 18-wheeler size generator parked outside. Yeah, that's not going to be good. But what you do is you put a place of refuge. So you'd have maybe like one area, like the offices or the classrooms. You have some area of it that's zoned for a place of refuge. If you needed a building, I do a lot of work with low-income multifamily projects, and they might be 50-unit buildings or 300-unit buildings, and they need to have places of refuge, and they're all going high-efficiency heat pump, new construction, or renovations. So they'll do places of refuge, community areas in the building that they'll zone off of a VRF heat pump for that space that's on generator power. That way it's a normal-sized generator. It's not the entire building, and that's the way to get around it, because we won't be winning it if we try to do the entire building on a generator.
I did skip over a couple of questions I wanted to come back to. Several people asked about, did you also look at the building envelope, insulation levels, et cetera, and a couple of people said, your building looks relatively new, Richard, but a lot of houses of worship are much older buildings. And how would that factor into a project like this in one of those buildings?
Okay, so Quinn Abbey needs a new roof behind me, that's for sure. So yes, we look at enclosures and mechanical systems together to see how they interact and what needs to be upgraded. If the idea of what we should be doing over time is to drive down the load of the building and to look at what the enclosure requirements are. There have been some improvements here over the space of this project that happened incidentally, like with the roof improvements, the added insulation as well. And there are some openings that were in the sanctuary roof that's gotten closed off and air sealed during this project as well, just incidentally. But we were looking at the enclosure a bit, just as a side view of this project, some issues. We do look at the enclosures to see what could be upgraded over time. But we need to understand that we haven't found a building owner that has all the money to fix every problem yet. And that is one of the issues, is how do you tackle these over time, and which is the biggest concern that needs to be tackled now?
Well, I can pass on because I talk to the folks at Mass Save a lot, and particularly in the Eversource territories, they are really focused on houses of worship, and they are paying 90 and in many cases 100% of basic insulation and air sealing. And I'm sure a lot of these buildings have non-standard stuff that might be outside of that. But it's a really good time if you are thinking about looking into your insulation and air sealing in your building. Call up Mass Save and take advantage of their focus on that, because as Wes, as you said, the first thing to do is to lower the load of the building, and so that's something on their minds. Couple of stray questions that didn't fit into these other categories. One, as you mentioned, there was still a fossil fuel boiler that was relatively new that you left. Is that only backup, or is it serve a particular area of the building? What is its role now?
I think that's RTU.
Or the RTU?
That was left.
Okay. Yeah, okay.
Yeah, because we did leave the one RT. I mean, that was the one we'd replaced about a year and a half ago. So that did need that, right? That was the reason. Yeah.
That serves some of the upstairs offices. And that's kind of like one of the, so when I first started talking with Richard, going back like a little over a year and a half ago, it was a case that RTU had failed and then had been replaced. And then another RTU was on the way out. So we knew we had to start looking at things there at the building. But because that one was just replaced, there's no point in ripping it out. And that's not good for the environment either, just ripping things out and throwing it in the landfill.
Well, there was actually a question that came in. Is there any market for, say, like a 5-year-old piece of equipment? Which I guess they're very excited about moving into decarbonization. But again, if it's relatively new, you hate to just rip it out and put it in the landfill.
Scrap deal. Scrap metal.
Yeah.
Yeah.
I hope it was all put to recycling.
Jim, you actually asked me a question earlier on our email exchange. Why didn't we do this earlier? And I actually meant to cover this, and I just slipped my mind. It's a great question. It's an easy question to ask, but a very hard question to answer, or at least to get buy-in on. Because if you've got an HVAC system that's running just fine, and nothing is failing en masse, so it's not at the end of life. So, you think about it, how do you put this forward to a congregation that we need to spend so many millions or hundreds of thousands of dollars just thinking to the future? And I don't know the answer to that. Certainly, we shouldn't have run our equipment to death, and that things were just dying exactly on schedule. But it's a hard thing, because also you don't want to do things piecemeal. I think if you just, it's at which point do you bite the bullet and say, we're not going to put another gas burning boiler in there, or air handling unit or rooftop unit. And maybe it can be done. Wes and his design team, I'm sure, could come up with a plan that's, slowly one by one, you can start to put things in. But I would assume it's not the most efficient way to do this project, to do that kind of replacement. Wes,
I think
what
that
have you seen over time? I mean, I think it's a good question for you. If organizations haven't wanted to go 100% switch over, or haven't had to go, how have you seen it done?
If they have to do 100% switch over?
No, saying if they want to start switching over, but they don't want to do the whole thing at once. I mean, what's the typical approach for that?
Yeah, it depends on what kind of systems are there now. So let's say in the case of your building, it was ducted to certain sections of it. So it'd be trying to take those RTUs out or air handlers out and switching them over one by one. But we reused some of the ducts, like say the ELC side, we reused the ducts that were heating both the lower level and the upper level to be repurposed for energy recovery ventilation. So we'd have to knock out the heating. We'd have to use the opportunity for taking out the heating upstairs for the ventilation downstairs. So it ends up, there's ways to do it, but it really depends on what the systems are there. Each building is a little bit different than the next. But there are all different ways of doing it.
Yes. I will just say that I was doing an energy assessment at a house of worship this past weekend where they have a boiler that dated back to the 1960s. Still working for them,
yeah.
But they're aware that maybe we should start thinking about replacing it. So I think part of it is I see it's kind of the Yankee frugality a bit too. It's like, if it ain't broke, let's just keep using it. Why, until it dies, and then we'll worry about it. But again, that's not the best approach, because they only die, when it's 10 degrees below zero out. And then everyone's like, we have to get something in right now, and then you're kind of stuck. I see, Fred, you've got a hand up, and I know we're coming to the end of time here.
This is great. And Jim, thank you so much for managing the very good questions that were asked here. And to the speakers, thank you so much for handling them. It was fantastic. I do have a perhaps closing kind of question for you, maybe for you more for you, Richard, than anyone. But how special do you think your synagogue is, your congregation is? And what I mean by that is, you showed us your mission statement early on as a guiding as guidance for your decision making, which was fantastic. And by the way, I just want to insert here that Jewish Climate Action Network used that very statement and others from other synagogues and is coming up with a model policy for synagogues. We're coming out very soon with a climate policy for synagogues. And all of that to say, so I thank you for the input to that. And I'm putting it to you to ask, would you say that statement, or adopting that statement at some time in the last few years, helped you get to this stage? Do you think you were very special, or do you think any congregation can do what you did?
Well, we're special for many reasons, but relating to this question, I think they can. You've just got to have the commitment and also the knowledge. I came onto the board 4 years ago. I didn't know about that statement. And actually, one of my board members, our social justice board members on the call tonight. And when we started this project, he said, we do have a mandate that any project we take on has to be considered in light of this environmental justice statement, which I actually didn't know. And right off the bat, then that's changed my thinking, and knew that the task force we put together was going to be comprised of different people than I initially thought. And I knew we could do it. And if we can do it, I mean, there's a lot of very forward-thinking people and progressive leaning folks in New England, where most of you are, I think, tonight. And I think absolutely, you're all special and you can all do it.
You have given us hope. Thank you so much.
Sure.
A related question actually just came in about, it sounds like you had a good, strong set of moral arguments that tied to your climate policy, but there was also the whole practical side of it and the way the finances worked, where it had little to no impact on the budget. So kind of, which one kind of swayed more people, or was just different people are swayed by different facets of the prep?
Operating a temple, from what I understand, or a synagogue in the 2020s is very different to what it was 15, 20 years ago. And obviously you need a financially stable and well-run synagogue with either stable membership or growing membership, because you really can't do these, I think, at least at this scale, if you have a dwindling congregation. And that's just the reality of, I guess, spirituality and religious, affiliations in this day and age.
Well, we are coming right up on 8:30. We have like 1 minute. So last call for a question or for a hand raising. Otherwise, this has been really, really insightful. And again, very inspiring. A lot of hope to see that this can be done and can be done in a way that is, very financially responsible. That's probably the biggest, I think, concern a lot of people have in a project like this. So it's a fantastic case study.
Okay.
Seeing no questions, I will turn it back. I guess, Eric, are you going to close it out? Or Fred, are you going to close it out?
I'll let Fred close it out, but
I'll let Jim close out. I opened it up, and Jim, you speak for all the houses of worship in Massachusetts. Take it home.
Yeah. All right. Well, I know that this will be an example to houses of worship across all different faith traditions. And Richard, I want to get in touch with you and actually write this up as an official case study that we can post on our website and that Fred, you can share with your membership. But I think this is a great timing for this too, because I have seen over the last couple of years more and more houses of worship, getting into that mindset of we really have to do something and we have to think beyond just the like for like kind of replacement. And I know, Wes, you've worked with another congregation who is doing a big analysis of their building, and some of the people who came are people that I've worked with on that and brought here. So everyone else who is maybe earlier in their thought process of approaching a big project like this, I hope you've gotten a lot of good information, a lot of good thought stimulators to get you on that path. Know that, Fred at JCAN and I at Mass IPL are here to help you, as I know Wes and Jody and Eric and the folks at GreenerU that I'm working with on a couple of other projects are here to bring their expertise and experience to try to make these projects as painless as they can be. They're hard, they're big, but when you have good, solid people and good, solid companies like this, that we heard about the planning, we heard them talk about considering the different needs of congregations and making sure that their work is compatible with the continued use of the building and the continued execution of the mission of the organization. It's really, really super. So,
Jim, how about a year from now, we aim for a follow-up program, and we'll have other follow-up programs in the meantime. But a year from now, we come back for the next 30 congregations that went heat pump, because Shir Tikva went first.
Works for me.
Hallelujah. Thank you all for joining tonight.
Indeed. Thank you and good night.
Thank you.
Thanks.
Bye.